Let me introduce you to my Warco drill press. But could it be improved? In this episode we'll get the control panel wired up, then we'll try out some of the buttons. Jog up, jog down, and then emergency stop. Then we'll start the motor up for the first time. After that we'll get onto the lighting system and then install the PTC temperature sensor. Finally, adjust some of the parameters to get the motor running just so. Welcome to episode 9. Okay, so I'm just offering up the control box to make sure it's all going to fit, and then we'll put the side panel in and mark the entry for the cable that's going to come in through here. I've run out of these mushroom style screws, so I've just got the regular cap screws and whatever else I had. So I've got a load of those on order, so I'll replace those when they arrive. Okay, we'll put the front panel on next and just make sure we've got clearance in through the side, and then we'll put the side panel in. There's the control panel. Go on there. As you can see, just down here, it's very close. There's a few millimetres gap, so clearance is clearance. So that's fine. So I think the best place is to come in here, where we've got quite a bit of space, and then we can spread the cables out from there. Okay. So I'll mark the hole, drill that out, get the fitting in. I'll bring you back in a minute. Here's the side panel. I've drilled it, put the fitting through to hold the cable. So I think what we'll do now, we'll feed the cable all the way through and then drop this in. Just make sure it's all going to work and fit. Okay, so what I've got to do is get all of that around that 90-degree elbow. So it's a bit fiddly, so I think what I'll do, just put some masking tape on it. Double check I've got the nut on it, and there should be a rubber sleeve. Where's the rubber sleeve? No, here it is. Right, got to put that on next. That would be annoying if I threaded all that through and then forgot to put that on. Is that everything? Yes. Right, here we go. You can see down there, not easily, but let's try it again. Come on. I think we got it. All right. And does it fit in there? Hopefully it'll give clearance at the back here. We'll find out. There we go. So that looks okay. And then, can we still get this on? Okay. Right, all I've got to do now is wire this to this. Okay, let's give you a quick update on where we're at. So we're making some progress here. So you can see I've got some of the connections already made. So I started out by making the connections for the ones internally that were just on the control panel. So making jumpers across there. I've also got common down here, connects to all the commons together. And then I've just started making this kind of breakout lead that goes to this connector here. So there'll be a couple of these connectors, but they'll be unique. So there'll be a 6-way, a 4-way and a 2-way to make sure that you can't plug them in the wrong way. You don't send 12 volts down the wrong channel. So that's how it's coming together at the moment. So I've got 2 more breakouts to do. And I'll just give you a quick tour of all the bits of kit that you kind of need to do these kind of jobs. Okay, so over here we've got all the different terminal connectors. So I've got the ring connectors. I've been using these if the cable's particularly large, but otherwise I've been using the size lower than this, which is the blue. But I've just run out of that. I don't have any more in stock, so I've been using this fork type instead. Now, because it's only low voltage, I'm pretty happy to use that, but usually I'd go for the ring terminal, especially if it was mains voltage. But I've got some more on order, just haven't got those in stock at the moment. Just working my way through those. So they're the spade and ring terminals. And over here I've got various assortments of wire cable labelling, so you can put all the different numbers on. Just helps if you're then going to try and cross-reference that to the circuit diagram, helps with diagnostics, or if in the future you come back to it and you want to add something, at least you know what goes where. And then I decided to use, on the panel itself, terminate it in a connector, as I just showed you a moment ago, rather than try and wire everything from the main cable into here. It's a bit fiddly to do that, so I'm going to use these little connectors. They're fairly inexpensive, and I think for what I need, these will be fine. They're not waterproof or anything like that, but I don't think that'll be a problem. They come in different types, different ways. So I've got, there's a 4-way there, 3-way. So I'm going to use a 4 and a 3, and then somewhere in here, there I've got a 6-way as well. And they've got a male and a female part, so if we take, I think it's those two, yeah. So they go together like that, and then they've got that little positive lock feature in there. And all you need to do is make up the pins, crimp on, just make sure you get the right one in the right end, and the pins just crimp on, and then they've got a little one-way tang there. You insert those, and once it's in, you can't get them out unless you get a screwdriver in and press that down, then you can release them. I use this one here. So this style here, it's got this kind of little heart shape, I guess you might call it, at the back there, and I'm using the number 1. I found that gives the best performance with that style of connector, and you just crimp that together and it crimps around the wire and holds it pretty tight, so that works pretty well. While we're over here, I've also got, this is for doing your spade connectors, so you've got your different, or ring terminals, you've got your different colours there. This is the ratchet style, which I really like, because as you crimp it down, it doesn't let you undo it until you've gone all the way, and then it will come undone, which makes sure you get the right tension on the joint. Always worth pulling the cable afterwards and make sure it is actually secure. If you get part way through and you start to crimp it and then the wire falls out, or you want to abandon it, there is a little release down here. So if we just push it, there you are, so you can get back out again if you're in trouble. But these are really good. These ones were made by Kennedy, but I don't know, have a look around and see what you can find. But I really rate those. And then I quite like this style of wire stripper as well. This is the style where the wire goes in there. There's a backstop, so you can set the depth, and then you just do that and it pinches it. If you've got really fine wire, this can break the wire, so you're probably better off using a little knife and your thumb or some other method. But for moderately sized wire, like, you know, this sort of size, main size, this is perfect. You can cut really quickly with those side cutters. The multimeters, to make sure I understand on here, just double checking I've got the right connectors that I intend, either the normally closed or normally open, whichever one I'm supposed to be wiring to. And then we've got the wiring diagram. So I showed this in one of the earlier videos, but we'll just go over it briefly again. What we basically got is the inverter and the power supply side. So everything sort of in this dotted box over this side is in the control box itself, or the big one on the wall. And what we're trying to do is wire up this side, which is the control panel, which is this panel here. So this is basically on the right. And what we're trying to do is essentially get back to having junctions here between these 1 to number 12. So we've got this one going off to our emergency stop, these ones going to start, stop, these ones going off to the forward reverse. We've got our jog buttons down here. And we've got 3 down here which come from the potentiometer, which do the speed, and then we've got our earth. So this is earthing the main body back to the main earth. And this is where we need to make up those, the 2-way, I think I'm going to use, I'm going to use a 3-way, a 4-way and a 6-way to cover all these. So there'll be 1 or 2 spare, but that's fine. Okay, so that's the wiring diagram. I'll just hold it there in case you're interested in that, but that's how I'm intending to do this. So the way it'll work is you've got the emergency stop, which will break the 12-volt signal from here, and that will in turn cut out the relay back here and the machine will completely stop. You've also got your momentary start and stop buttons, and what these do is feed power back to the relay that's in the main control box on the wall, and that latches this. So this latches in an on state, and then the machine continues to run until you hit stop, and then it breaks the latch. Once you're in the latch mode and these 2 contacts come over, you're energizing itself, and you're also enabling the common, this 0 black wire common, well it's not 0 I guess, common DCM back to here. And that's really the main common that pulls down either your forward or reverse. All these different controls essentially link up to the X4, X5 and X1, and it's via these switches they get earthed back to that DC common back there, so long as it's energized and you're in the run state. So that's kind of that side. And then down here you've just got your potentiometer, just a simple potentiometer here. I think it's 10 volts in here, your analog common at the bottom, and then you've just got the variable 0 to 10 volts here that comes out this, in my case the blue, into VL1, and that determines the actual speed of the motor. And then we just mentioned that that's the earth down there. So that's what I'm following this on this side. And then where I was making those joints, or showing those joints earlier, these are the joins where things join together, all the commons join together. I think there was one more, yeah there were a couple more where I've got to join more than one together. So I started there, joining those together, and then I'm just making the flying leads that go off to these connections here. There we go. So that's it, very briefly. Hope you followed that. I was just looking back at that video, I noticed my fingernails getting a bit long. Yeah, looks better. So anyone who's ever wired up a control box or a CNC control cabinet knows just how long it takes. It just seems to go on forever. Every little cable takes a few minutes to route it into the right place, get the right connector on. Keep double checking your wiring diagram to make sure you're on track and you're not making any mistakes. There might be a few fiddly bits in there as well. Just seems to take forever. But there's only one way to get it done, and that's just to keep going until you get to the end. Okay, so here we've got the first 4 connectors, so that's 1, 2, 3, 4, and then 5, 6, 7, 8 of these, 5, 6, 7, 8, and then the potentiometer, that's 9, 10, 11, and then 12 is earthed on the main box up here. Right, we'll double check that and then make a start on the other end. So you can see the controls have got the potentiometer hooked up. Let's give our speed. Start, stop, forward, reverse, jog up, jog down, and then emergency stop. Yeah, okay. Try that again. Emergency stop. Perfect. Right, let's make a start on the other side. Okay, that's the last one. So they're all done, labelled up. Let's just shrink those down and then we give it a try. Oh, before we do that, there is one more, which is this one, which is a spare one. Right, I guess it's time to make the connections. Somewhere in there. There we go. That one. Yes. Okay. Okay, now the big question, does it all fit? Nearly. Try that. Okay, as you can see, I ordered some more M5 button head screws. And there it is. Yeah, looks really nice. Very pleased with that. Well, I guess there's only one thing left to do, and that's to switch it on and see if it runs the motor. Okay, looks like it's all come on okay in there. You might notice I've just disconnected the fan just there. That's because I want to put a diode across there just to protect the transistor from the spike that you get from the relays when they switch on and off. So we'll hook that up properly in a bit. Let's just see if the main function works first. Okay, with a bit of luck, when I press on, it should run the motor. Let's just set it to medium speed.
Sorry, couldn't resist. This is what really happened.
Let's just set it to medium speed. Fantastic. Okay, that's forward. Reverse. That jog. Needs a bit of work on the parameters. It's a bit slow. And brilliant. So you might notice throughout that looks like the motor's running completely the wrong way for everything, but that's okay, we'll just switch it round on the connections in there. Brilliant. Let's try the emergency stop. Fantastic. That's a great step forward. We're really pleased. And this pulley didn't look very concentric on this tapered bore here, so there might be a bit of dirt on the taper. It might need cleaning out, or it might just be that it's been cast and machined not concentric. So have to think about that. Right, just fire it up again. You can see it up close. I'll just run it really slowly. Somewhere in there. There we go. That does not look very true at all. The one on the motor at the back, the small one, looks fairly okay. Although looking at it from here, perhaps now it might have a bit of run out as well. Come to think of it, the drill did have a little bit of shake to it, and that's probably why. Yeah, there's quite a lot of run out there. Don't tell me I'm going to make my own pulleys. There's not going to be much left of this by the time I finish. Still, it's got to be right. Right, I'll go away and have a think. Okay, so let's change the direction of the motor first. There's a couple of ways I could do this. One is to change the wiring in the control box, but it's already got UVW on there and I don't really want the hassle of moving the wires around, so we'll change two of the connectors up in here instead. Plus I need to get in here anyway to wire up the PTC, the temperature sensor, in through here, which is inside the motor itself. So let's get this cover off and swap two of the wires over. Okay, so these are the three phases coming in. 1, 2, 3 there, and then the earth. All we need to do is just swap two of those over. I think for convenience we'll just swap these lower two. Now triple check the power's off, so that's not a problem. So we'll just swap those over, and here's the temperature sensor that we need to wire up as well. So I'll bring that in a minute. Let's get this swapped over. So that needs to go in the centre, and that was at the bottom. Put that in the middle. There we go. Could have done that with the top two, it doesn't matter, any pair, just swap the direction. Okay, I've already terminated the cables, so we've got those crimped on, we've got some heat shrink and a little bit of tubing just to bring it up to the correct size so this cable gland will clamp on it correctly. Now the PTC, positive temperature coefficient sensor inside here, just the temperature sensor effectively, all it's doing is providing a resistance, so there's no polarity here, it doesn't matter which way around we connect it. Now this should just sit there and all be well, but I did check it and that it would be possible for that thread of that live terminal to go down that hole. If it managed to go around like that and touch it, I mean it's unlikely, it should just sit there really, nothing should happen, but just in case I'll put some electrical tape around it. And the last thing to do is just tighten up the cable gland at the top. Only plastics, I'm just going to do them finger tight. There we go. So we've got our temperature sensor wired up, let's put the cover back on and we're finished. Okay, looks good. Okay, well I still need to do something with the wiring. I've got a little cable guide I think I'll use to put all the cables on, but we'll do that another time. Right, another job done. As you probably saw in an earlier video, I've put the bayonet fixing for the lamp inside here, and we've got the cable coming out the back. I've got that now wired up to the control box over there, and I've got an inline panel mounted fuse in there. I'll show you that in a moment. But first, let's put the bulb in. It goes in through here. So the original bulb that came with this was the incandescent type, so I swapped it out not long after for this LED one. It puts out a nice bright light. So what happens is, so the live feed comes in through here, goes into this fuse holder. So here's the outer view of that panel mounted fuse holder here. The top unscrews like that. And then it takes this style of fuse here. So this is 5x20. As you can see, this is a kind of instrumentation type of fuse, so it's about 5 there. Just a touch under 20 probably, yeah, because it's spring loaded. Yeah, but notionally 5x20. Not to be confused with the regular sort of fuses we'd have in the UK, which go into the plug itself. So these are generally quite a lot larger. So that's probably, I think it's an imperial size. Yeah, looks like it, doesn't it? Yeah, 1/4 inch by who knows what. 25.4. What's that going to be? Okay, so it's inch by 1/4, so it's pretty old size. But anyway, it's a standard. That's all that matters. So that's what goes into a regular plug. Okay. But what we need is the little instrumentation size one. So that goes in there. Put the top on. And that just makes the circuit. Okay, so this is a 1 amp fuse. You can get these in a range of sizes, starting I think about 250 milliamps, maybe a bit lower, but in very small increments all the way up to an amp and then beyond, depending on what you need it for and what circuit it's going to go into. So I think an amp feels about right for the lighting circuit here. Okay, let's plug it in and see if the light comes on. So as soon as I switch this, it should come on straight away. Here we go. Perfect. Yeah, casts quite a lot of light. I think that'll work really well. So it's an LED, so you get a nice bright sort of white light of it. The only thing I'm a little bit cautious of is there's going to be sort of stuff here. So there's going to be like a quill support here, so I deliberately cut a hole in it to make sure the light can come all the way down and come through that. If these components get in the way and block it too much, I've got the option of having an auxiliary light sort of on a stand on the side, or on kind of an arm, because there will be an arm here that holds a DRO on, so I think it will be combined with that. But you know, we'll see how we get on. But for now, very pleased. Yeah, looks good. so I've just installed a diode across there, sometimes called a flyback diode. So it's just across the coil of the terminals of that relay, which means when it switches off and the magnetic field collapses, it doesn't send a voltage spike back to probably the transistors that are inside here that are switching it, which won't do them any good. Instead, it'll just release the energy through that diode itself. So with that in place, when we fire it up this time, we should see the cabinet fan right at the top there start up. So let's turn it on and just see if that comes on. Let's power on. And then if we press start on the drill, hopefully you can see it there, the fan has come on, controlled by this relay here. Fantastic. I'll switch off. Okay, so another job done. Let's have a little look at the speed controller here. So behind here is a potentiometer and that varies the speed. And originally I bought these little knobs to go on it with a little indicator on. I think I got 10 for about $1, something like that, so very cheap. And they were very, I think you'd probably have to tap that on lightly with a hammer. It's a very tight fit on there, and I'm sure that would work, but now I'm seeing it on there. You can imagine when that's fully home, you can see a lot of the nut that's showing. It's got maybe a bit of a plastic finish. You're going to be turning that quite a lot to vary the speed. And I'm just thinking, oh, I'm just thinking, maybe we can do better. Okay, so there we go. So we've got a recess here for the nut that holds the potentiometer on, then the shaft will go down there with that 6mm bore. Got a knurling on there, give you some grip, a little bit of a chamfer. I decided not to chamfer the rear edge, and then it will give it a nice sort of more flush appearance. Just polish that front edge up a bit, and then we need a little grub screw in here, or a set screw, to lock it onto the shaft. And I was thinking of machining a little groove in here and putting some black in just to give us a little pointer. That'll look quite nice. Alright, looking good so far. And here it is all finished. So we've got our little paint indicator there so we can see what position it's in. Little M4 grub screw there just to lock it onto the shaft. Bit of knurling to give it some grip. Well, let's put it on. There we are, our speed control. So it goes a little further than the indicator, but that's okay, because most of the time it will be somewhere in this range, I imagine. So that's fully anti-clockwise, so that's that'll be off. I think it will start somewhere around there. So most of the time it will run through there and then full speed there. And it sort of matches the other. I've got the sizes very similar to these, so it's very close. Yeah, looks quite nice. Certainly better than what I was going to go for, which is this. Yeah, very pleased. So we've got our speed control. Okay, so now we need to set up the motor parameters properly. So we've got the acceleration rate and deceleration rate. We've got to do a few other changes as well. So these are the sheets that I made up myself from the single sheet of instructions that you get with the inverter. And this is a little bit easier, I think, for me to read and understand. So we've got the green ones are the main ones to get the motor running. The blue ones are optional, but they're sort of tuning parameters you might want to do, like where you want start, stop to happen. The grey is not applicable or not implemented for this model. White is more advanced, or probably you don't need to really touch that unless you really want to dive into some detail. So we've got that page there, got that page there. The purple I didn't talk about. The purple is for physical input and output, so how you're going to start, stop it with the switches and so on, all the configurations. There's a video I went into detail on this a little bit earlier in the series, so if you're interested, go and check that out. So it goes to there, and then the last page is to there. So the first one that I need to do is I emailed the motor supplier and asked them what the maximum speed was. I currently got this set to 120, and they advised 90 was about the top they recommended, so we'll change that back down to 90. And the other ones we're going to change are the acceleration rate down here and the deceleration rate. Then we need to change the jog frequency, the forward one reverse. I want reverse to be a lot quicker, so I want to go in quite slowly and then come out quickly. We'll play around with the velocity, so the acceleration rate you get for each of those, the rising and descent velocities. And I think that's it. So let's go to the inverter and get those programmed in. Okay, now to program it, we obviously have to have this switched on. Now I've made it so all the connections, it'd be really hard to get your finger on any of the live terminals, they're all buried down inside here. But still we're going to stay well away from that, and we'll just be using the program section over here. So let's plug it in, switch it on. So the first one we're going to do is the maximum operating frequency, which is currently set to 120. We want us to set that down to 90, so that's program 6. So you might remember from an earlier video that I made this little crib sheet about how to get into the programming mode and the buttons you press, so I'm going to be following that system there. I won't go into detail on this, because if you're interested, go and check that video out. So let's go and get this set up. So we need program 6. And then let's go and see what's stored in there. So we press function, it's going to go 120, so we need to drop that down to 90. When we're happy with that, we need to press function again. And so that's gone in. Good. So done the first one. Actually, let's just check that works. So let's come out. So now it should run to 90. Okay. Putting it at 0. Set that in the middle. Nice. Right, next next one? Yes, the next one is 34. Oh, 34, too far. Okay. I want to go into that one. It's currently set at 10, so that's 10 hertz per second. Let's run that. Let's try 30. So that'll be 3 times as fast to accelerate. Now, I've got no chuck in there. I've got no huge drill bit, so the inertia is going to be wrong. So we'll just try this. We can always come back a bit later if it starts tripping out when it's got really big cutting bits in, but we'll try 30 for now. So we're happy with that. So press function end. That means it's gone in. That's good. And while we're here, we'll do the same thing on program 42 to make it stop a bit quicker. Now you've got to be careful on this because it's going to be dumping all that power into the inverter, and there's no brake facility on this, so there'll be a limit before it will trip out. Okay, so we've gone into there. It's currently 10 as well. Let's try that 30. Function end. So we're good. Come out of all that program. Right. Hopefully it doesn't trip out. Let's see what happens. Oh, a lot quicker. So we've got no inertia in here, we've got no chuck, we've got no cutting bit, so that will put a little bit extra load on the motor and put a bit extra load on the inverter as well, which has got to absorb electrically. So do we go a bit higher? Let's try that again. Yeah, let's just try one more. 34. And then what's stored in there? Currently 30. So let's try go one more. Do you know what? Let's just do 50. Why not? So we're happy with that. Press function end. That's good. And then 42. Same thing. It's currently 30. Change to 50. Okay, end and come out. Alright, let's try that. It might trip out, let's see what happens. It's certainly a lot quicker. Well, I won't go any quicker now until we've got a proper load on here, but that feels okay. Right, good start. Right, now let's do the jogs. Alright, so we need number 86. 86. Currently we've got 20, so that's the jog forward speed. Let's drop that down a little bit. Okay. And reverse, we'll put that up, so that's 87. Yeah, it's currently got 20 in it, so let's go up. Let's go to 50 on that one. Not gone too far. Okay. And then 88, that's the acceleration rate. Okay, so let's see what's currently in there. Oh, come out. Oh, damn it. Currently got 25. Okay, so we can make that faster than that. Let's go a bit peppy on it. Alright, 60. Okay, put that in. And for 89, what's in there? It's currently 25, so we'll do the same thing. Install that. And we're good. Come out program. Right, let's try the jog. Okay, so if we jog down. Oh. Ah, one of them worked. decel works, the accel didn't change, and the frequency was wrong. Apart from that, it's perfect. Right, I'll bring you back in a minute. Okay, so I had a little play around and I realised what I'd done is my original plan was not to use what they call the jog function because it's got some limitations if you do that. I mean, it's pretty good, but it's just got some limitations. So I was going to use the set speed, and I'd been setting up the wrong parameters. So before we go into that, let me just show you what now happens. So if we run it, that works nicely as before. We get a little bit of a ramp up. We're running at 41 or whatever we want to run at. So that works fine. If we jog, it now jogs to the set speed. So 15 Hertz. This is, imagine you're tapping. Maybe that's a little fast, we'll see. But it's very quick now, so it's got its own dedicated acceleration rate. So if you want to jog down, tapping like that, it comes on pretty quick. Now I'm hoping that, I know we haven't got the chuck on here, but taps are going to be generally quite small, so they won't have too much inertia, so I might even be able to get it a little bit more snappy than, well, not let's not say snappy when you're tapping, but a little bit quicker response. But I think for now that looks okay. So that's tapping in, and then we want to bring it back out again just to clean the flutes or whatever. We can come back out like that. So you can see that runs to 15 Hertz for the tap function. All good. So let me show you what's going on. Okay, so the problem was I was playing around with these jog functions here, 86 to 89. This is the built-in jog functions. This enables you to jog forward at a certain speed, reverse at a certain speed, but the acceleration rate to the acceleration deceleration rates, you've only got these two parameters, so you can't independently tune those. Basically, those apply to if you're going forward or reverse. And you might want to tap in relatively slowly and then come out just to clear the chips and then go back in again, tap a bit more slowly. So to give a little bit more freedom than this offers, no, this is fine, but to give a little bit more freedom, I realised I'd gone with a different strategy, which is here I was going to use the set speeds instead, which is parameter 27. So I've just been playing around with that. Parameter 27, which is the set speed when I invoke the jog function, and then parameters 35 are for the acceleration and 43 are for the deceleration. Now, as currently configured, that's actually no better off than the jog before, because you've got the speed you want to run at, you've got the acceleration and deceleration, so basically the same as before. But the advantage of doing it this way is you've got the option, if you remember there's a spare wire in the control box, is the orange cable I think, you'd have the option of configuring that to link up to set speed 2. So you could, in the future, if you really want to do this, you could have speed 2 linked to a different set of accelerations, which would be 36 and 44, and therefore when it goes down it would be set speed 1 to whatever you want for speed 1 acceleration and deceleration, and then set speed 2 when you come back out again, which could be a different acceleration, deceleration, and even you could come out very quickly as well, you come out to a higher speed. So it gives you a bit more flexibility. And just if you look at the wiring diagram, just trying to explain what's going on there, I'd actually even made a note to myself when I'd made it. To make this work, you need to set parameter 27 to 20 Hertz, that's the jog speed, because I'm using the jog function. It's got a set speed to do a jog function. So I'd even made a note of to myself there, but I'd forgotten all about that because I did this a while back. The other things you'll notice on this is when you press the jog buttons, they've got, sorry, the light catching. When you press the jog functions, you've got the two contacts, so it connects two pairs together. The first one is to say, yes, I want to go forwards in this case, so it makes that connection to DC common. So if you connect that to common, it knows you want to run forward. But if you also make the connection, so it's this connection down here, to X1, it knows not only do you want to go forward, but ignore the potentiometer, but run at the set speed that's dictated by parameter 27. And to make it do that, this X1 function, you've got to, this is quite complicated, so sorry about that. You've got to set, here we are, parameter 50, which is the X1 input. What do you do when it sees X1 shorted to common? What do you want it to do? And the answer is, in this case, set it to 13, which is we want to run at set speed 1, see parameter 27. So when you short those two out, it knows you want to, let's call it jog, and run at that speed. And 27 is down here, and that was the speed I was setting. So maybe that's starting to make a little bit more sense if you're still following along here. The only thing to note is that when I jog the other way, yes, now I'm making the connection that that connects reverse to DC common, so it knows it wants to run the other way. But I'm also then, because those two are tied together, you see they both, that one and that one, oh, where is it? They're both tying to X1. Here it is, yeah. So this one goes to X1 to common, and this one goes X1 to common. So at the moment, they both just use X1, they both just use 27, which means if you jog up or down, you're still getting the same speed and acceleration. But doing it this way, rather than those being common, you could have another wire. Remember, the orange one is spare. And instead of linking it that, you would link it to a spare one, let's say X2. And then for X2, which is here, rather than it being whatever it's currently defaulted to, you would link it to speed, or number 14, which would be speed 2, which is parameter 28. And parameter 28 is here, so that's speed 2, and then you've got an independent acceleration and deceleration. So in other words, rather than being stuck the same up and down, you can have a different speed when you go up and down. That's the long and short of it. And that's why I did it that way, and that's why it wasn't working earlier, because I was just using the jog functions, but I hadn't configured the inverter to run like that. Right, so there we go. Hopefully that makes sense. Let's go and draw a picture. Right, so let's start with the general running. So when I just press start, and just run it according to the potentiometer. So if we draw what's actually happening here. So if we've got time along that axis and speed, it's in hertz, but this is speed. And if you remember, the first thing we did was we set the maximum speed to 90 hertz. So actually let's just draw that accelerating up there, like that, and like that. So this number here, this was parameter 6 on this inverter, and we set that to 90 hertz. So that's the maximum speed of the motor. But of course we can't get there instantaneously, we've got an acceleration, so that's this slope here. And that was set by parameter 34 on this inverter. And I think I ended up setting that to 50 hertz per second acceleration rate. So that's how quickly it accelerates. This is if you're going clockwise, which generally you draw clockwise. I mean, yeah, left-handed draw bits, so like you might go the other way, but the theory is the same, it's just in reverse. Okay, so we're accelerating up according to parameter 34. We get to top speed determined by parameter 6, and then we want to decelerate when we want to stop the other side. And that one is parameter 42, and I think we did the same. Yeah, we did 50 hertz per second for deceleration. And for general just drilling holes, that's essentially what we do. Accelerate up to the speed. Well, this speed may vary. This depends on the potentiometer. Actually, it wouldn't go any higher, but it's somewhere between there and there would be your potentiometer. Okay. And then you just drill holes and vary the speed accordingly in there. Right, that's fine. So let's talk about the jog, or jog in quotes, because I'm using the set speed function for that. So we draw our similar diagram. So now we're going to jog clockwise, so we're tapping our hole. We've got our time down here, and we've got our frequency here. Now our max was up here, was 90 hertz, wasn't it? But when we're jogging, we're only going to jog to, I think it's around 15, so say it's about here. The other thing is, if we look at that slope, that acceleration, let's say it's sort of like that, for that one, we want this to be a lot quicker. So we've set that an awful lot quicker. It gets there very quickly, holds at that speed as long as you press the button, and then it decelerates pretty quickly as well. So we got that. So then this maximum speed this time is set by P27, because this is one of the set speeds, and that was 15 hertz. Now to be able to do that and tell the inverter we want to, when you press jog, when you press X1, look at this speed, we needed to set parameter 50, because that's what X1 as an input looks at, and we needed to set that to 13, and this means use whatever's stored in here for your set speed. Okay, then you've got your accelerations up here, and this one was P35, and I actually ended up setting that to 70 hertz per second, because we're not accelerating that quick, we haven't got much inertia, we've just got the tap, and so we can accelerate pretty quickly. Again, we'll see how we go, but I think we'll be okay with that. And then when we come down the other side, we've got the deceleration, and that was parameter 43, and again that's 70 hertz per second. It could be something else, but that's what we went with. And that is to jog going down, but it's important that you have to tell it, because in the wiring diagram not only are you telling it please go forward, so shorting X4 to DC common, but you're also saying shorting X1 to common, and when it sees that, because we've told it, or when this gets shorted to common, this X1, then do whatever's stored in function 13, which is go to parameter 27, which is 15 Hertz, if that makes sense. Okay, if you didn't set that, if you set that to something else, it would do something else when you did that, and yeah, depending on what you set it to, it would go and look at a different parameter. So we're using it like that. And then when we jog the other way, now we're coming out the hole. So we've got time down there. I'm going to jog out. So that would be, that was that way, it's that way. Again, we're not going very fast, so well, I guess we could actually come out a little bit quicker, because you're probably not going to break a tap coming out, or less likely to. But for now it's set the same, but you could make it different. Well, you could make it different. Let me explain how. At the moment it's set to P27, which is 15 Hertz. And you'll notice that that's the same here. So whatever speed you're going down, the speed you're coming out is the same. And the acceleration is set to P35, which is 70 Hertz per second, and the deceleration is P43, which is also 70 Hertz per second. So it's the way it's configured now. These are the same, the acceleration's the same, and the deceleration's the same, the way it's configured now. But what you can do, if I'd said, I think it's P51, which is the X2 input, let me just check that, I think it was. 50, yeah, that's right. So for the X2 input, which are the inputs on the top of the inverter, so if we'd set that to be, I think it was 14, at the moment I'm not using it like that, but if you did that to 14, then it would use P28, and this one would be, it would use P36, and this one would be P44. Again, let me just double check that, I think that's right. 36. Yes, that's right. And that would use that orange wire, so you'd run another wire. And so if I want to run it independently in the future, I can get that orange wire, connect it to X2, run that out to, instead of daisy chaining the two sides of the switch together for up and down jog, I just have an independent orange wire and do that. Program that, and there we go, up to 2 speeds. If I use the jog function that's built in, I couldn't do that, so that's why I did that. Okay, well, I think that's pretty good progress. So we've got the control box made up, wired in, we've got the speed control sorted out, we've got the motor reverse, we've got the PTC sensor wired in, we've got the lighting sorted and working and fused, we've addressed the top speed, had a little bit of play around with the acceleration rates. I can probably do a bit more fine tuning on that, but I think it's somewhere to start. Yeah, I think that's it for this video. Hope you've enjoyed, thank you very much for watching, and we'll see you next time.